Hello everyone, good afternoon. कैसे हैं सब? How are you all doing? मेरा प्यारा 11th standard का बच्चा लोग, everyone give me a very big hi in the chat box and do also tell me how are you all feeling on this very fine Friday. You all are gonna welcome the weekend, right? So before you enter into the weekend, tell me what you're feeling on this particular Friday. What all plans you have made for this Saturdays and Sunday? So once again, this is Ameer, your physics educator at Unacademy, and those who love me more, they simply call me Bhaiya, right? So what we are going to do in today's session? We all know the chapter, a Kinetic Theory of Gases. It's a chotu nannu munu chapter, right? But still, there is lot many concepts, lot many numericals waiting for us, and we don't want to leave any marks from this particular chapter, right? So obviously, in today's class, we will be solving many numericals from this particular chapter. And once again, we will make sure that we will not be losing any marks, or instead we'll be getting the full marks from this chapter after you attend this particular session. So I hope you all are ready. Before that, let me see what is happening here in the chat box. Con hai. How much excited you all are for the session, everyone. Hi Yumi. Hello. Hey, I'm from Haryana, Passion for Arts. Okay, good to have you here. Sudhi Vijay. Hi. So nobody has told me till now. Okay, what are you all doing? Kaise hai sab? Everyone, jaldi, fatafat. Good afternoon, good afternoon, good afternoon, every one of you. ठीक है, बढ़िया बात है. Now, I know that many of you might be seeing me for the very first time. A bit of introduction about myself. I hope you all can see it on the screen, right? I'm a beta graduate from NIT Calicut in mechanical engineering. I taught and mentored many students for more than 3.5 years. It's almost going to be 4 years now. Okay. So yes, that's all about me. More you will come to know as we proceed with the classes. Okay. Yes. Moving on. Now, you can have a look here. If you don't want to miss any of the live classes from our channel or from all your favorite teachers, you can be a part of the Telegram channel. All the updates will be given there. The link is given here and also in the description box. Bugs Bounty, what is it? It's an amazing program which can help you to grab a lot of prizes. What you all have to do? You just have to go to the description. There you'll find a form. And fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, Anna, you will be given with, or you will be rewarded with so much of gifts, let's say. So you can keep on waiting for all those gifts soon. Okay. Moving on. I know that many of you are unaware about this subscription platform, right? So here we have the Plus subscription platform. Look, here we'll be having the live classes, weekly test, structured courses and everything. Now, if you go for the iconic subscription, you will get all the features of Plus, plus some extra features such as a personal mentor, someone to help you plan with your academic activities. For every academic activities and whatever help you need for that, this person will be there. Then light out solving classes will be there. What will I say? Progress reports will be given every week, so don't miss this opportunity. Now, if you go for 12 months of subscription, it will cost you 1,250. Lekin the good news and the happy news is, as you are attending my class, I'll be giving out the code which is AMB10. Users get 10% of discount throughout all the time. Okay, so don't miss your opportunity. Now, for iconic, if you go for 12 months, it should cost you 2,333 per month. But again, we don't have to pay that much. You will be given straight 10% of discount once you use the code of AMB10. Users, enjoy your life. Okay. Now, moving on. Have a look here. Now, whatever doubts you have related to Unacademy, the platform, how it works, which are the courses available, for anything, you can get in touch with the counselor. The number is given here. Okay, open house session keeps on happening. You can come and join for all the open house sessions and get more and more close to all your favorite educators. Now, bachalo, offer is going on. If you make 3-month subscription, extra 1 month will be given free. This is available only for the first 500 subscribers. Yes. So, aaja sab. Okay, waiting for every one of you. ठीक है. Now it's time for our session, isn't it? Session का वक्त आ गया. Tell me, are you all ready for that? बच्चा लोग पूरा का पूरा ready? Just tell me, just yell out from there. Yes, sir, we are super ready. I just want to know that. Siddhi, Deebu, Bari. Ready? Siddhi? Awesome, awesome, awesome. Right? So we are having lot many questions from the chapter of Kinetic Theory of Gases, which we exactly are going to solve in today's session. Good afternoon, Mithalesh. Good to have you here. Okay? ठीक है ना? So as you all are super ready for the sessions here, right? Let's get started. The very first question is right in front of you. So have a look at it. ठीक है? अच्छे से, नन्हे से, मुन्ने से, प्यारे से, ठीक है? And start solving the question as fast as possible. So whenever you come to physics class, your motto shouldn't be only solving numerical problems at the same time. Your motto should also be to increase the speed of mathematical calculation. I'm expecting that from you all. So yes, keep it going. Mithilesh already gave me the answer. Mithilesh, one time you don't have to spam there. ठीक है? Give me the answer once. That is more than enough. वो तो बिल्कुल बढ़िया है. ठीक है ना? Anyone else? Jaldi kar le. It's a very simple question, so everyone can do it. Obviously, I'm going to explain within no time. Okay, so whoever is doing the problem from there, you can keep on doing मेरा बच्चा लोग. In the meanwhile, I'll also keep solving from here. ठीक है? Let's make this competition. Let's see who's gonna win first. Your bhaiya or you people. देखिए, a gas is an environment that has a volume. Initial volume is given. How much? Red doesn't work properly. है ना? We'll take white color. So initial volume is equal to 16.8 liters and it has a pressure of 3.2 atmosphere. Okay. Now if the volume changes to 10.6 liters, if the final volume is equivalent to 10.6 liters, what will be the new pressure? P2 will be equal to how much? And that is the question mark. Now here, though it is not directly given, we'll have to assume that the temperature is remaining as a constant, right? They have mentioned that it's in an environment. So we'll have to say that in this environment, temperature is remaining as a constant. Else we cannot solve this problem. We'll have to assume, okay, temperature is a constant. Okay, if temperature is remaining as a constant, it's very simple. According to Boyle's law, we know that what? P1 V1 is equal to P2 V2. Start substituting. The only unknown will be P2. You will be getting the answer just like that. P1 kya hai? Where is P1? 3.2. Okay. What is V1? That is 16.8. P2 we don't know. We'll write it as such. V2 is 10.6. Okay. So how much is this going to be? This is going to be 5.07. P2 value 3.2 16.8 by 10.6 का value हो जाएगा almost 5.07, right? Not liters, it's ATM. Because here we have considered the unit of pressure as ATM while we were applying this particular Boyle's formula. ठीक है? So the final answer has to be in ATM itself. Don't make a mistake there because here we have Pascal unit also. So don't jump and go for that particular option there. Clear? Everyone? See, the answer C is confirmed. Very good. Yummy. Licky option C. Deebu bol raha hai ki C. Badhiya baat hai. It's a very good. Okay. That was very good from every one of you. I'm so happy. Okay. Any doubts? Array, from this question, I don't think anyone can have a doubt here. है ना? So yes, let's jump to the next one. अगला question कहाँ है? अगला question तो इधर है. Same. Okay. You first 3 to 4 questions is directly from that ideal gas equation or the derivation of ideal gas equation. Those laws such as Charles law, Boyle's law, Avogadro's law. Right? So initial part of the questions are from that topics only. Anyway, कोई बात नहीं. It will be a practice for you. So keep on doing it and keep on giving me the answers. जल्दी से. Oh, Mithilesh already gave the answer. Super fast. which is 0.517 liters, right? So yes, keep it going, keep it going, keep it going. Anyone else? Anyone else got the answer? I'll just read the question, okay? Then also, before I start explaining, I'll check who else have given the answers. ठीक है, देख ले. A gas occupies a volume of 400 centimeter cube at 0 degrees Celsius. You know that whenever we use any gas equations or any gas laws, temperature has to be in Kelvin. Don't forget to convert this. Okay, and 780 mm of mercury. Okay, so how many liters of volume will the gas occupy? At 80 degrees Celsius, initially it was 0, now it is 80, matlab temperature has increased, but pressure is remaining the constant, 780, 780. Okay, so it is the volume and temperature which changes. What is the relationship between them? Array, if pressure is remaining as a constant, at constant pressure, what can I write? At constant pressure, we can write V1 by T1 is equal to V2 by T2. Any doubt at this? No. What is the initial volume? That is 400, right? Divided by, what is the initial temperature? Array, 0 degrees Celsius. Don't substitute it as 0, you will get infinity. Hai? So 0 degrees Celsius is equal to how much? 0 plus 273 Kelvin. How much? 0 plus 273 equal to कितना? 273 और क्या? Okay. V2 हमको पता नहीं, ठीक है, पता नहीं है तो ऐसे ही लिख ले. Just leave it as such. Temperature T2. Okay. How much is the temperature? It comes to a final temperature of 80 degrees Celsius. So to that add 273. So this is 315, 3. So this is the final temperature T2 in Kelvin scale. Substitute for T2 is equal to 353. So V2 is equal to 353 divided by 273 into 400 मिल जाएगा 517 with the unit of centimeter cube. देख ले, we have considered the volume with the unit of centimeter cube. So the final answer has to be in centimeter cube. लेकिन options are in liters. कैसे convert करेगा चलो? कैसे convert करेगा? We'll write here. 517 centimeter cube is equal to 517 into 10 power minus 3 liters. Centimeters to liters multiply by 10 power minus 3. So this will be equal to 0.517 liters. And answer आ जाएगा option C. Have a look. Obviously, the method of doing this problem is very simple, right? We need to use V1 by T1 as V2 by T2. Lekin, there are so many mistakes that we can happen. First of all is in the temperature conversion assay. Second thing is a unit conversion of a volume from centimeter cube to liters. So all these things if you take care of, then obviously you'll get the correct answer. वही है ना? So in the meanwhile, who all have given me the answer? Good afternoon, Anera. C confirmed. Very good, Deepu. C. Correct answer. Finally, C is correct answer. Obviously, finally C is correct answer. Okay. So have a look for 5 seconds on all the steps. If you have any doubts, you can ask me, or else we can jump to the next one. Ready? Ready, Anna? Okay. Good afternoon, Pooja Yadav. So, ठीक है, we will proceed to the third question. कहाँ है हमारा third question? इधर ही है. Okay, so yes, do it. Good afternoon, good afternoon. C's answer, Shruti. Okay, Shruti. 12 liters is what you say for this. Okay. लेट्स सी हमारा आंसर 12 लीटर आ जाएगा या नहीं। तो प्यार बात चलो जल्दी कर ले एंड गिव मी दी कीप ऑन गिविंग मी दी आंसर्स। एनीवन एल्स? Okay, so many of you are going for option, Deebu is going for option A, Mithilesh also has gone for the option A there, very good, ठीक है, let's see हमारा option A है या some other option it is, ठीक है। 1 mole of helium gas fills up an empty balloon to a volume of 1.5 liters. What would be the volume of the balloon if an additional 2.5 moles of helium gas is added? Array, pressure and temperature तो constant है. We know that in that case, volume directly proportional to number of moles, right? Or V1 by V2 equal to N1 by N2. Bas. If you know this, and if you know how to take the numericals from the question and substitute it here, मिल गया. Initial volume 1.5. Okay, so final volume पता भी नहीं. Initial number of moles, it's 1 mole, right? Final number of moles, there many of you will make the mistake. Is it 2.5? Is the final number of moles 2.5? No, that's wrong. देख ले, read the statement again. If an additional 2.5 moles is added to the already existing 1 mole, we are adding 2.5 more. So total will be 1 plus 2.5, which will make it as 3.5. So the final number of moles is 3.5, not 2.5. So V2 हो जाएगा 3.5 into 1.5, इसका आंसर हो जाएगा 5.25 liters. बस मिल जाएगा हमको. We will get the answer as option A here. Not a big deal and simple, isn't it? It's very simple. Correct answer. What is it? सर मुझे डेंटल मिल रहा है गवर्नमेंट कॉलेज से, एडमिशन ले लूँ या ड्रॉप ले लूँ MBBS के लिए? It's all up to you, Aneera. If you want to go for MBBS, just listen to what your heart is saying, ठीक है? And just listen to it. You don't have to go for others' opinion. Whatever you want to be in your life and whatever makes you happy, do that. So simple, right? Obviously, like I said, the initial first 3 to 4 questions will be nannu munnu, easy direct questions from either gas laws or ideal gas equation. ठीक है? ठीक है ना? Karan? Okay, fine. So we are proceeding further, okay, to the next one. Oh, one more question from Avogadro's law itself. So देख ले. This you can do within seconds. सच में बता रहा हूँ. This question है ना, you can actually solve it within seconds. ऐसे कर सकता है. Anyone already? Mithilesh has gone for option B there. Good. Deebu with B there. Jia with B there. Jia, okay. Deebu with B. Atharva नहीं आया, कोई बात नहीं. Aneera with B. Rupali with B. अरे obviously. देखिए. A tire initially has 10 moles of air occupying 40 liters of volume. And half its volume is being lost due to what? Due to the puncture. Okay, to that tire, the tire got punctured and half the volume of air has been lost. Considering pressure and temperature constant, what would be the amount of air in the deflated tire? We know that. If pressure and temperature, if it is remaining as a constant, we can say simply volume is directly proportional to number of moles. What can we say? We can say volume is directly proportional to the number of moles. That's it. So, what is happening? Volume is becoming half. How? Because half the air is moving out of the tire because the tire got punctured, right? So, half the volume is lost. So, the remaining volume in the tire will be half the initial value. Okay? So, if volume becomes half, as they are directly proportional, number of moles also becomes half, right? So, if volume becomes half, number of moles becomes half. Initially it was 10, half of 10 is 5. So the present value of number of moles will be kitana? 5 moles. Are directly proportional. In simple words, volume proportional to number of moles. Volume becomes half, number of moles become half. That's it. 10 will become 5. Simple hai? Okay, such a way. It's so simple. Anyone can do it. Isn't it? Correct answer. Very good. Okay, everyone who got the correct answers, and at the same time, whoever is trying out there, who is trying out there so good to get the correct answers, you guys are also winners and very good. Congrats on that. Okay, so nothing more to stay with this particular page. Let's move to the next one. Here we have the next. Let's see how many of you can give me the answer for this. Soon after this, okay, we will be done with the gas laws, and the questions from gas laws will be entering into all the other parts of this particular chapter, which is equipartition of energy, okay, and kinetic energy, then specific heats, molar heats. Into all those topics we are going to slide in. So be there, be prepared. And in the meanwhile, who all have given the answers for this? कौन दे दिया? कौन दे दिया? Anyone? कोई भी नहीं. What happened? What happened? No one. I don't know, sir. Okay. क्यों नहीं? अरे नन्नू मुन्नू है. A container with a volume of 71.9 milliliter. Volume is given. Contains water vapor at a pressure. Pressure value is also given. At a temperature of 465. Temperature भी दे दिया है. How many grams of the gas are in the container? कैसे? How can we find out? Very simple. We know the ideal gas equation is PV equal to nRT. Any doubt in that? You shouldn't be having a single doubt. N corresponds to number of moles. Number of moles is given mass divided by gram molecular mass. R into T is equal to PV. Okay, this 2m, right? The mass of the gas present, that is a question. For that, rearranging, M is equal to PV capital M divided by R. Now start substituting. 10.4 atmosphere. We know that atmosphere is not our SI unit. It is Pascal. We should also know the conversion. 1 atmosphere is 1.01 into 10 power 5 Pascal. So 10.4 atmosphere is equal to 10.4 into 1.01 into 10 power 5. Okay. Now volume is 71.9 milliliter is 10 power minus 3 liters, and obviously liter is not also the SI unit of volume. We know that 1 liter is 10 power minus 3 meter cube. So 71.9 into 10 power minus 3 liters, how can we convert into meter cube, which is the SI unit of volume, multiplying it with 10 power minus 3 once again. 10 power minus 3 into, it's water vapor. What is the mass of water vapor? 18 grams. Okay, why I am not converting grams to kilograms? देख ले, final answer is in grams itself. ठीक है. whole divided by R value is 8.314 into temperature is 465. Don't forget to convert by adding it with what? 273. So that degree Celsius will be converted to Kelvin scale. 465 plus 273. Now nothing is left. Ab baki kya hai? Sir, there is a big huge calculation that is left and still you are saying kuch bhi baki nahi hai. I'm leaving that to you. ठीक है? So if you do the math here, you'll be given 0.222 grams, which will be your final answer for this particular question. Okay, देख ले everyone, देख ले कोई भी डाउट है तो जल्दी पूछ ले and बता दे. आ गया ना? अभी आ गया? Okay, very good. Someone was telling, sir, not able to do this problem, लेकिन now I hope you can do it. And ये तो simple. It's based on simple ideal gas equation. Anybody can do it. Just like anybody can dance, A, B, C, D, movie is there, right? This, anybody can do this problem. Got it? ठीक है, आ गया ना? Who said that? Prateek. Very good, awesome. So we will proceed to the next one. Agla question. Now read this question very carefully. जल्दी से. किसी ने दे दिया क्या? Mithilesh is going for option B here. Sania A, B. I didn't know that. In MCQ questions, right, we can actually find the answer or we can choose two answers. पता भी नहीं था. Sania, superstar, right? Anera, very good. It's option A, sorry, option B. Let's see. A flask contains oxygen, hydrogen and chlorine in the ratio of 3:2:1 mixture at 27 degrees Celsius. Matlab, all the three are at the same temperature. Molecular mass of all the three is given. Question is, find the ratio of average kinetic energy per molecule of oxygen and hydrogen. So tell me, what is the total kinetic energy of one single molecule? F into half kBt, right? F into half kBt. So here the question is to find out the ratio of kinetic energy of what? Kinetic energy of oxygen to kinetic energy of hydrogen. That will be equal to F, degree of freedom of oxygen, which is a diatomic molecule. How much? Diatomic degree of freedom, how much? It's 5. So this is 5 into half kBt whole divided by kinetic energy of hydrogen. Hydrogen is also a diatomic, so degree of freedom is 5 into half into kb into t. So are you not writing T1, T2? Arey dekh le, all the three is a mixture and all of them are existing at the same temperature of 27. So temperature be same hai. Dekh le. Is the complete numerator and denominator the same? Yes, it is. So what will be our answer? It will be option B, which says 1:1. Clear? Every one of you clear? अच्छे से, नन्हे से, मुन्ने से, प्यारे से. Sure, B is the correct answer. Yes, it is correct answer. Very good. Meru, good evening. Correct answer, Simple Dimple. Okay, awesome. No doubt at all, right? So basically, if I give a simple explanation about this particular question, dekh le, You simply have to know this particular formula for total kinetic energy of a single molecule, that is F into half kBT. If you know this, doing this problem is not at all a big task. Okay, fine. Any doubts? No, right? सब बढ़िया, right? You got a fever and era, everything will be fine. Okay, no worries at all. ठीक है, ये तो बढ़िया बात है. ठीक है, so अगला क्वेश्चन पे जाएगा. Almost same kind of concepts, but question is totally different. जल्दी से everyone. Read the question, try to do it by yourself. Mithilesh is like A and B both are correct. Okay, fine. Let's see. Then anyone else? Rashita is going for option B. Sanjay is going for option B. Okay. Srihari waves in the revision. I will be soon informing you. Prateek B. ठीक है. Fine. Let's solve this. Everybody listen. Okay, this is a beautiful question which has most of the concepts from equipartition of energy and RMS velocity also. देख ले. A gas mixture consists of molecules of type A, B, C and D with molecular masses Ma, Mb, Mc and Md. Two statements are drawn from it. First one, average kinetic energy of four types of molecules are in the mixture are in the ratio. Tell me, what is the formula for kinetic energy of 1 mole or average translational kinetic energy of 1 mole of molecules? How much it is? That is equal to 3 by 2 RT. Okay, now as you can see, all the four gases is actually a mixture. All the four are being mixed together and all of them are at the same temperature. 3 by 2 and R is already a constant. So as it is so, the kinetic energy translational for all the four gases will be the same. So EA by 1 will be equal to EB by 1 is equal to EC by 1 is equal to ED by 1. If you remove this one, all the energies it will be equal. Kyunki because they are at the same temperature, obviously they has to be, right? Okay, moving for the second part. RMS speed of the molecules of the four types are in the order. How can we get RMS speed here? देख ले, kinetic energy speed we have. How will you write kinetic energy speed as? Half mv square. This v is the RMS value of speed, that is equal to 3 by 2 RT. Half cancel. V RMS is equal to root of 3 RT divided by m, which means the RMS speed is inversely proportional to the masses. Whichever has larger mass, here in this case it's A, will be having the least value of speed. Next larger mass is for B and this next largest will be for B, because as the masses keeps on increasing, speed keeps on increasing. Kyunki there holds an inverse relationship. Any doubt? कोई भी doubt है? देख ले, you don't even have to by heart the equation for RMS speed because you can easily derive it from here itself. So by heart only this formula, remaining equations are going to come from it. ठीक है? Fine, every one of you. Okay, I saw Aryan, thank you so much for your compliments, but it's fine, you don't have to spam out that. So option A is correct, option B is correct, so we can go for the second option, which says option the statement A and the statement B are correct. ठीक है? Yes, Shruti, Abhima, Prateek, all good. Any doubts? Jaldi se पूछ ले. Just ask all your doubts as soon as possible here in the chat box. Correct answer, Mithilesh. Awesome. Very awesome. Very good. Are you all going to ask me any doubts here? And if you don't ask me, I'm super happy. I can just do the question, right? But keeping away like kidding part, right? Okay. Keeping away the jokes, I would really appreciate if you ask me the doubts, because if you are asking me the doubts, it makes me think that yes, you all are super interested for learning this particular topic. Okay, fine. Okay, fine. So yes, moving on. मेरा बच्चा लोग अगला क्वेश्चन आ गया है अरे let me see, ये कौन कौन करेगा, ये कौन कौन करेगा? I really want to see. Okay, I'll be looking into the chat box all the time. Kinetic energy for ideal gas. Kinetic energy for ideal gas, how will you find out? For 1 mole of any gas, the formula for kinetic energy is equal to F into, right, half kBT. So what is the postulate? I am not asking, right, to ask a theory out from somewhere. I ask like whenever I'm giving you questions, right, and whenever I explain that particular question, if you come across those doubts, you can ask me. Or instead you will be like, sir, prove PV is equal to half N kBT. Then I'll be like, Arey, this is not the time for asking me to prove something, right? This is the time for you to ask me any doubts you come across whenever I explain any question. Okay. So anyone already have the answers or what? Mithilesh is going for the option A. Sania A, Mithilesh A, Eka 47, Prateek. Okay, Rashida is the only person with a different option. Shruti with a different option with C. Anera, Bimas. Okay, everyone is going for A. Let's see whether it is option A or option C. Okay. The pressure of an ideal gas is dash to kinetic energy of translation per unit volume of gas. Okay. Starting with kinetic energy. Okay. Tell me what is the translational kinetic energy ka value, that is equal to 3 by 2 RT, isn't it? Okay, the translational kinetic energy is equal to 3 by 2 RT. सबको पता है, ठीक है? Now, for n number of moles, that will be equal to n times RT. Okay, for 1 mole it is 3 by 2 RT. For n number of moles, it is n times 3 by 2 RT or 3 by 2 nRT. Here we have to introduce pressure, क्योंकि the question is to make a relationship between pressure and kinetic energy. अरे nRT का वैल्यू क्या है? Anyone who doesn't know this formula? I don't think, right? सबको पता है PV equal to nRT. So nRT I'm going to substitute as PV here. So this is equal to 3 by 2 PV, that is kinetic energy. So rearranging, pressure P is equal to 2 by 3 KE divided by V. Question देख ले. Pressure exerted by an ideal gas P is dash times kinetic energy of translation per unit volume. Kinetic energy per unit volume. Kinetic energy per unit volume. So what is that numerical value which connects pressure and kinetic energy per unit volume? Is it 3 by 2? Which many of you have gone because of you all making that silly mistake. Which one? It's option C, right? Only 2-3 people have given me the option C as correct. Right? I do remember it was Shruti and one more person was there. Okay, right now Vaishnavi also, very good. Okay, fine, good, clear. So have a look at all the steps. Jaldi se note kar le. You have 10 seconds for noting down. 10 seconds. Sir, A is correct. ठीक है? If you want to learn that by your own, it's up to you. Okay. So it is 2 by 3 times. Any doubts? So the final answer is 2 by 3. No, I suppose. Let's jump to the next one. And here we have. So concentrate. Try not to make a mistake this time. And expecting correct answers from every one of you. Mithilesh is already there to give the correct answer. I'm not telling correct answer, said answer, right? Whether it is correct or not, we are going to soon confirm. Let's see. Let's see whether it is option C which is the correct one or not. Everyone keep on doing it, keep on doing it. Okay. Once you are done, let me know. Question is visible, है ना? Is this troubling you? I'll just pull it out. Chum, chum. नहीं चाहिए हमको. Okay, we'll start. Right? Okay, here we go. A flask contains argon and chlorine in the ratio of 2:1 by mass. Okay. The temperature of the mixture is 27 degrees Celsius. Obtain the ratio of RMS speed of the molecules of the two gases. Atomic masses of both of them are given. Okay. So before making or before finding out their ratio, let's first have an equation for RMS speed. How many of you do remember equation for RMS speed? We already have derived in one of the question we did before, right? So I'm going to write it directly. That is 3 RT divided by M. VRMS is equal to, those who don't know, copy it down. Okay, it is root of 3 times RT by M. R is universal gas constant, T temperature, M is the molar mass. Now both of them are at the same temperature. Okay, so VRMS is only proportional to, VRMS is inversely proportional to what? The molar mass, isn't it? Yes. So VRMS of which one? Atomic mass of argon. Obtain the ratio of the molecules of argon. So VRMS of argon to VRMS of second one is chlorine is equal to root of, it is inversely proportional to root of mass. So argon by chlorine will be equal to molar mass of chlorine divided by molar mass of argon. Any doubt? No, right? Okay, this is equal to root of, what is the molar mass of chlorine? That is 70.9. Molar mass of argon, that is 39.9. मिल जाएगा आंसर 1 point. Any doubts? कोई भी? Any doubts? If anyone is having, let me know. $1.33 होगा सर. हाँ 1.33 ही होगा and हो गया भी, and here we have the answer for that also. No doubts, I suppose, है ना? Okay, fine. So just copy it down. Take 5 seconds for copying. Tum, 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 tum. ठीक है? Tum, tum, tum. हो गया, है ना? Yes. Let's move for the next one. Here we have. So once again, it is the RMS speed of hydrogen at room temperature. Okay. Same kind of question, like in a chotu difference is there. Instead of finding ratio, they are asking for to find RMS speed directly. Alright, just use a formula which we already know, substitute kar le, get the answer. इसमें क्या है? Right? So let me see who's the fastest mathematician here. Are we flash, sir? I know that you guys can't do all the questions just like that. That's why I say I'll be giving you initially 30 seconds. So usually I start solving the problem after that. That you can keep on giving me the answers even when I solve, right? So you have time first 30 seconds, then you have time till I solve. You got this much of time. इससे ज़्यादा time कैसे? How can I give you? Right? क्यों देना है आप लोगों को? ले कितना generous teacher हूँ मैं. I'm giving you extra 30 seconds, then I'm solving here. So मैं तो बढ़िया ही है, right? Okay. So Shruti B, Mithilesh is going for B. B होगा Sergi, Vishal. Okay, so everyone I suppose is solving it. So keep on solving it. ठीक है? And I'll be giving you the answers. देख ले. RMS speed of hydrogen. Formula क्या है? Root of 3 RT divided by molar mass. Root of 3. R is 8.314. Temperature is how much? 300 in Kelvin itself. So no need of conversion, right? M corresponds to molar mass of hydrogen, that is 2 grams. So 2 converting from grams to kilograms, multiplying it with 10 power minus 3. हो गया, हमको मिल जाएगा आंसर एज 1.93 into 10 power 3 मीटर पर सेकेंड. सही है? अरे we have to do this numerical value if you know the equation, right? So if you know the equation in exam hall, most of the time we'll be stuck with the equation. In which situation? When we don't get the particular formula, right? When we are not able to derive a particular formula which is required for solving that equation. If all these things happen, we usually get stuck. You'll be like, "Arey, kaise karega?" And with that tension, you will be forgetting many other things also, right? So keep yourself cool. Try to by heart as many formulas as possible. By heart matlab keep on writing down the formula and try to by heart it, so that you'll never forget. ठीक है? So ये हो गया ना? So 5, 4, 3, 2. In the meanwhile, who else have given the answers in the meanwhile? Okay, Ayan has given option B. Ravish has given option B. Okay, nice, done. Okay. Fine, all good. Awesome. Super great. ठीक है. So we're gonna proceed further. Okay, fine. Next. Read the question. All these questions will simply make your concept super strong. I believe that, right? And yes, you all can do that also. Jaldi. Okay, news updater. Very good. Vishal, you are handsome. Array. Thank you so much. So, answer Galib polls it's A. Anyone else? Okay. So, keep on solving. Everyone keep on solving the answers. Fine. So, you can keep on giving me the answers in the chat box too. Okay. In the meanwhile, I'll also solve. Have a look here. A tank used for filling helium balloons have a volume of contains 2 moles of helium gas at 20 degrees Celsius. Fine. Assuming that the helium behaves like an ideal gas. First part of the question. What is the total translational kinetic energy of the molecules of the gas? What is the formula for that? Kinetic energy total for all the molecules present. Alright, if it is for 1 mole, kinetic energy is 3 by 2 RT. Translational kinetic energy is 3 by 2 RT for 1 mole. So if it is for n number of moles, n times 3 by 2 RT. Okay? And this is exactly what we are asked to find out. Start substituting n, 2 moles, right, into 3 by 2. R is 8.314 and temperature is 20 degrees Celsius, that is 273 plus 20. Okay, so itna hi karna hai. Any doubt in that? So basically problem comes to choose which formula, right? Usually whenever a question is asked related to kinetic energy, the problems comes mainly from this particular part is like which formula we have to choose, because we have 3 by 2 RT, F times half RT, F times half kBT, right? So first understand all these basics. Okay, so understand all these basics here. I'll write down if you want. Dekh le. So ye clear hai na? Is this clear? So answer will be option C here for this if you do the mathematics. Okay, so I know that many of you have a doubt when to use that formula, when to use this formula, wo kab, ye kab, ye kab, wo kab. Okay, I'll tell you everything. Dekh, everybody listen, listen, listen. I'll give you a very good idea on this. Okay, now kinetic energy associated, okay, with one single vibration of motion or for one single motion, right, that is equal to kinetic energy for 1 degree of freedom, that is equal to half kBT. Kinetic energy for 1 degree of freedom for 1 molecule. Okay, now kinetic energy translational, total translational kinetic energy for one single molecule, it's not mole, for one molecule, right, for one molecule is equal to 3 by 2 kBT. Okay, kinetic energy translational for one single molecule. Okay, now next one is kinetic energy total, all kinds of kinetic energy, let's say rotational kinetic energy, okay, translational kinetic energy and vibrational kinetic energy, total for one molecule is equal to F times half kBT, because we know for 1 degree of freedom for one molecule it is half, so for F degree of freedom it will be F times half kBT. Okay, now kinetic energy for 1 mole total will be equal to half into R into T, right, with F. Just convert Kb, Boltzmann constant, to R, universal gas constant. That will give you kinetic energy for 1 mole total. Okay, and last one is kinetic energy for n moles total. Formula is equal to n times F into half into RT. So if you know this much, हो गई बात. That energy translation, right, or energy distribution questions pop up from only these many formulas. If you know when to use all these formulas, then done. Okay, one more thing, translation for one single molecule, it is 3/2, right? Okay, so kinetic energy translational, right, for 1 mole, not for one molecule, for 1 mole is equal to 3/2 RT. देख ले, for one molecule it will be Kb, ठीक है. When you want to write for one complete mole, which is 6.022 into 10 power 23 particles, just replace Kb with R. That's all you want to do. Okay, that's all you want to do it here. For one molecule it will be Kb, and for one mole it will be R. So if you know this basic things and basic concepts, है ना, you can do any questions which comes from this energy part. Okay, fine. Good afternoon. You're back. Good to have you here. So this, है ना, before we proceed further, everyone copy this down. Copy it as a short note. Very important this is. Very important. Okay, jaldi. Once you are done, बोल दें हाँ sir. Done, 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 done. Okay, fine. So shall we proceed to the next one? Okay, as you know all these concepts, now finding answer to this won't be a big task at all. So average kinetic energy per molecule for one single molecule. For one single molecule. The other one was for the entire molecule. Here we have one single molecule. In that case, what is the average kinetic energy? So do it expecting the answers from every one of you. Jaldi se. What is the average kinetic energy? Those who have written out all the formulas which I have given might have already started doing the problem, and you'll be very close to getting the answer, right? If I'm not wrong. Yes, you all are. Sir, I think C option is correct. Okay, who says? Shreya. Maru is going for option D there. All in one is like, sir, I'm giving you two options. Okay, whichever you find comfortable for you, just choose from that. Okay, Lakshman is going for D, Shruti is going for D. Let's all. देख ले, initial part of the question is the same as before. मतलब you have helium, okay, which has volume this much, 2 moles of helium, temperature भी दे दिया है. Question देख ले, what is the average kinetic energy per one single molecule? If I am taking one single molecule, what is the average kinetic energy? I'll take it to the previous page. What do we want? We want the kinetic energy total for one single molecule. One single molecule, how much it is? F times half kBt. Okay, so kinetic energy का formula है, kinetic energy for one single molecule is equal to F times half kBt. Tell me, what is degree of freedom for helium? Helium का degree of freedom कितना है? 3. Because helium is a monoatomic molecule, right? So that is 3 times half into Kb is 1.38 into 10 power minus 23 into temperature. Temperature कितना? 20 degrees Celsius, add 273 to that, we'll get in Kelvin. So 273 plus 20 is 293. So multiplied by 293. KB का वाला, I hope you all know, 1.38 into 10 power minus 23. Substitute कर ले, multiply कर ले, how much you will get? 6.07 into 10 power minus 21 joules. बहुत सही है, right? बहुत सही है, सिंपल है, नन्नू है, मुन्नू है और प्यारा भी है. So जल्दी से solve कर लिया. I hope you all got it. Okay, now it's time for you all to copy down. And I think those who haven't copied down this one, this is very important. Like I already have written, take a screenshot. Then you don't have to go through your Ncert again and again and again and again to get all these formulas in hand. Okay, now itself take a screenshot. Okay, and start writing it down, because if you know this much formula, na, whatever question pop up from this particular chapter, you will be giving the answer for it. Okay, done? ये भी सही है? Got it? Can I? Okay. Moving to the next one. Go for it, everyone. Again. Direct question from the previous chart. For this, I think you need only seconds, right? How many of you are going to give me the answer for this? Let me see. Con already have given. Who all have given the answers for this already? Mithilesh is C, Lakshman is D, then Pratik is going for C, Maru C, then Lakshman C, Shruti C. Arey wow, very good. Obviously the answer is half kBt. Like I told you, for one single molecule, right, for 1 degree of freedom, it is a half kBt. For one molecule, for f degree of freedom, it is f times a half kBt. Okay, so this is for one molecule. For one molecule, for per degree of freedom. For 1 degree of freedom is this. This is for one molecule for f degree of freedom. This is it. Question is per degree of freedom, that is equal to half kBt. Okay, so for 1 degree of freedom, multiply it with the degree of freedom of the molecules the question is asked about. Okay, fine. So हमारा answer for this is half kBt. सही है? Don't get confused by heart that chart which I have given you, everyone. Okay, then all these questions will be like silly question, silly question. Okay, so yes, moving on. Next, ये भी कर ले. Let me see how many of you are going to do this. And if you keep on solving these kind of questions, right, that concepts about equipartition of energy will be perfect. I'll say perfect. So yes, expecting the answers from everyone. Anyone already gave me the answers or what? किसी ने दे दिया है क्या? Mithilesh went for the option B there. Lakshman is going for option C. Shruti is going for option C. C. Okay, ठीक है. बच्चा लोग keep on giving me the answers. Fine. The translatory kinetic energy of a gas. Tell me for one mole. Okay. for one single mole, right, what is the total translational kinetic energy? वो भी हमको पता है, that is 3/2 RT. Okay, for one mole of any molecules, matlab how much mass will it be having? That will be having the molecular mass of that particular gas. Okay, so one mole का kinetic energy 3/2 RT का मतलब molar mass of gas is having the kinetic energy of 3/2 RT, because one mole has molar mass of that particular gas. Molar mass or m grams of gas has 3/2 RT. So 1 gram will be having 3 RT, 3/2 RT by m. For m grams it is 3/2 RT. For 1 gram it is 3/2 RT by m. Question is also that per 1 gram. So that is what we have found out, and this will be our answer, option B. How many of you have given the answers for that? कौन कौन दे दिया था? Shruti went for option B there. Pratik was going for option C. Now I hope you understood your mistake, right? It's not option C, it's option B. Okay. Thank you so much. Your variable batch is unbeliever. Clear all my concept. Thank you so much. Lakshman, yes, all in one. Dan, okay, fine, good, super great, no doubts. Done, 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 है ना? बोल दो हाँ सर, हाँ बिल्कुल समझ में आ गया. All the concepts are clear till now. I know that's what you're telling there. ठीक है. So moving on to the next one. There you all go. There you all go. Let me see. I've explained, I'm making you, let's say, super good, okay, super confident or super perfect in this particular topic of equipartition. So yes. Let me see. Okay, Mithilesh went for option D there. Option D. Lakshman is also going for option D. Vishal, option D. Everyone, be active. Give me the answer, jaldi. Everyone. Okay, D. Everyone is going for option D. Let's see how we are getting the correct option as option D answer. Question is, a gas has volume V and pressure P. Okay, fine. The total translational kinetic energy of all the molecules, not one single molecule, of all the molecules. Tell me formula kya hai? Kinetic energy total. It is not the entire kinetic energy we have to talk about. We only have to talk about the translational kinetic energy. Tell me, for 1 mole translational kinetic energy kitna hai? 3/2 RT. Okay, 3/2 RT for every kind of molecule, whether it is monoatomic, diatomic, triatomic, whatever may be the kind of molecules we have, translational kinetic energy for 1 mole, it is 3/2 RT. So for n moles, multiply it with n. So n times 3/2 RT corresponds to total translational kinetic energy of all the molecules present. ठीक है, देख ले, I'm going to rearrange this. 3/2 n RT. Okay, this is in all the cases, mono, di, tri, every cases. We know nRT का value क्या है? nRT is equal to PV. Substitute this. 3/2 times PV, and what is that? Kinetic energy translation. हो गया बात. So 3/2 PV, it's not a rho, that is the printing error. It's 3/2 PV in all the cases, whichever case, mono, di, tri, poly, tetra, octa, tuk tuk, tick tick, tuk tuk, कुछ भी हो तो, right? It doesn't matter to us, right? It is always 3/2 PV. Because whether it is mono, di or tri or poly or whichever kind of molecules we have, right? Translational kinetic energy is 3 by 2 RT. It doesn't matter. It's totally given here as translational. So yeah, keep in mind. कितने देर में? Obviously we'll be going at least for a time of 4 o'clock. At least for a time duration of 4 o'clock, we'll be continuing with this class. So done. Moving high, Chetan. So yes, to the next one. To the next question to every one of you. Rigid diatomic. Because for rigid and non-rigid, degree of freedom matters. Question is total internal energy of 1 mole of rigid diatomic gas is. Okay. So many concepts we have to apply. Okay, line by line, one by one. Then only we'll be getting to the answer here. Does anyone already have the answer? Arey baap re, my bacha logs are super good. Mithilesh, Lakshman, then Jasmine, all in one, Prateek. Very good. Many of you already have given. Those who are still or yet to give, jaldi se de de in the chat box. Okay, dekh le. In the meanwhile, I'll also explain. Total internal energy of 1 mole of rigid diatomic gas. First tell me, what is the formula for internal energy U? That is equal to N CVT. This is a formula. N corresponds to number of moles given as 1. So N is 1. CV का formula क्या है? CV is equal to F times R by 2 into T. Okay, fine. So now what we only have to substitute is F, then the answer is in our hand. Here we have a diatomic molecules. Diatomic molecules, there are two different cases. One is rigid diatomic. Okay, in rigid di, everybody noted down, very important, degree of freedom is 5. Because in rigid diatomic, vibrational energy won't be there. So 2 energy won't be here. So degree of freedom 5 hota hai. Vibrational energy mode is not considered. But in non-rigid diatomic, मेरा बच्चा लोग, degree of freedom कितना होता है? 7. Because in this diatomic, right, the already existing 5 plus 2 energy modes will be added, because here it is non-rigid, so vibrational energy mode will also be added. So extra 2 will be coming. That's why degree of freedom becomes 7 here in this case. Note it down. ये very important है. If you are preparing for JEE NEET exams and all, this is very important, because you usually learn it as 5 all the time. It is not 5 for diatomic, 5 and 7 also comes. Here in this case it is 5 because it is a rigid diatomic, degree of freedom is 5. So this is 5 times R by 2 into T, or 5 by 2 RT. Option A is the correct. So same question, non-rigid comes, it will be 7 R by 2 T or 7 by 2 RT. So keep that in mind. ठीक है? सर अब इंजीनियरिंग किस कॉलेज से किया है? अरे NIT Calicut. I think you were asking me for this for very long. Sorry, I couldn't answer to that. ठीक है, कोई बात नहीं. So note this down. जल्दी से फटाफट. And the answer is option A. Done. बच्चा लोग सही है, आंसर मिल गया, कॉपी भी कर दिया, डाउट्स कुछ भी नहीं है आई सपोज. सो अगला क्वेश्चन. डन. ओके, टू द नेक्स्ट वन. डूम. रीड एवरीथिंग प्रॉपरली, अच्छे से, नन्हे से मुन्ने से प्यारे से. Anybody already gave me the answers or what? Mithilesh went for option C there. Chetan C. Lakshman C. Now are you all going for the option C, everyone? Divya C. Everyone, those just go through the question, understand, try doing it in your own way. Okay, so everyone is going for option C only. Rita, Galib. Okay, cool. Let's solve it. Everyone, listen. In a gas of triatomic molecule, the ratio of the specific heat Cp by Cv. अरे Cp by Cv का वैल्यू क्या है? Cp by Cv is equal to gamma adiabatic constant. And adiabatic constant is having the formula of 1 plus 2 by F. Adiabatic constant is 1 plus 2 by F. F क्या होता है? Degree of freedom. Tell me, for triatomic molecules, what is the usual degree of freedom? The usual degree of freedom is 6. Okay, the usual degree of freedom, we usually take it as 6 for triatomic, and here we can apply 1 plus 2 by 6 is 1 by 3, that is 4 by 3, that is 1.333333333333. Okay, so we can go with the option C as our answer. Have a look here. So everyone start solving. I'll be giving you the next question here, right? Okay, tell me which one is the correct. Jaldi se, okay? So tell me बच्चा लोग, have you all got the answer for this? मिल गया या नहीं मिल गया? जल्दी फटाफट बता दे. Shruti is going for option B there, Lakshman is going for option B there, Rita B, Divya B, Lakshman, Davis. Okay, let's see, right? Which option is correct here? Question is, highest ratio of specific heat is possible for. We know that specific heat matlab gamma, right? Ratio of specific heat, that is 1 plus 2 by F. Question is, which one can have a largest value of gamma? Gamma will be maximum when degree of freedom is minimum. Simple mathematics, right? When F is a minimum, which is the denominator, this entire term will be maximum, or the entire 1 plus 2 by term will be maximum, right? So for large value of gamma, degree of freedom छोटा होना चाहिए, है ना, नन्नू मुन्नू होना चाहिए. So among the four given, which one has the minimum degree of freedom? It's helium, because helium is monoatomic, right? Monoatomic has the minimum degree of freedom, which is 3, right? Okay. So yes, that is our correct answer, which is helium, because oxygen is diatomic, degree of freedom is more than 3. Hydrogen is also diatomic, and air is a combination of many gases, so it will be having many degree of freedoms. Fine. Okay. Now I'm going to give you the next one. Here it is. Okay. So Jaldi say, start solving it. So, is it done, everyone? I just wanted to use washroom. That's actually fine. So, which option are you all going for? Everyone is going for option B, which says 5:7, right? Let's see. Okay. Now, question is, it goes like this. The ratio of CVs of 1 mole of an diatomic gas to linear triatomic gas. Which one it is, right? First, let us write down the formula for CV. Okay. So, CV का formula ये है कि that is equal to F times R by 2, right? So the value of CV totally depends upon the degree of freedom. है ना? Now tell me, what is the degree of freedom of a diatomic? For diatomic, degree of freedom will be equal to how much? That is equal to 5 usually. right? And what about the degree of freedom of triatomic? Okay, now I'll tell you, there are two different conditions, because you will be usually get confused with 6 degree of freedom and 7 degree of freedom. Now I'm going to make it clear for you. Everybody listen here, right? In triatomic, if it is non-linear, okay, as say if you have molecule combinations as like this, okay, if it is non-linear, I will write. I'm not going for the entire explanation. I'll write down the value here. It's 6. Okay, non-linear degree of freedom is 6. And in the case of linear molecules, okay, triatomic, one molecule like this, another molecule like this, and third one like this. Every atom's line, okay, for a given molecule. For a molecules with 3 atoms, all the 3 atoms will be lying in a line. That is called as linear triatomic, which is our case here. And here degree of freedom kitna hota hai? It will be 7. Is it clear? Fine. So degree of freedom triatomic will be equal to 7 here. Cool. Fine. All good. So degree of freedom of di to degree of freedom of tri will be equal to 5 by 7. Obviously, the ratio of CV is actually the ratio of degree of freedom. So both of them hold the same value, 5 by 7. Okay, CV is equal to F into R by 2. R by 2 is common for both. So CV is equal to F of di divided by F of tri, which is 5 by 7. And that will be our answer here, option B. Not a big deal, right? Yes, B is correct, mera bachcha log. Okay, yes, Nanu Munu. All good, yes, yes, yes. Awesome, super awesome. So, any doubts if you have, you can ask me right now. If you don't have, let us proceed. Okay, so let's proceed further to the next one. Agla question pe aa gaya. Now we are entering into the last part of this particular chapter, mera bachcha log, which is mean free path wala concept. Okay. So I think you do all remember mean free path, what it is, right? Okay. So the average distance a molecule covers between successive collision, right? That is called as mean free path. We know that molecules are in constant motion. So after colliding with one molecule, before it collides with the next molecule, right, how much distance it travels on an average basis? That is mean free path. We have a formula for that. By using this formula, you can easily do this problem, not a big deal at all. So yes. Okay, thank you so much, Mithilesh. Yes, fine, all good. So, इसका answer, how many of you know the answer for this question? किस किस लोगों को पता है? How many of you know? It's option C. Let's see kaise. The mean free path of the molecule of a certain gas, okay, a temperature is given, right, is this. Mean free path ka value is given. Question kya hai fir? The collision diameter is also given. ठीक है. Calculate the number of molecules per unit volume of the gas. Number of molecules per unit volume. Mean free path is given. How to find number of molecules per unit volume? Formula kya hai? Lambda is equal to 1 by root 2 pi d square. I'll introduce you to each and every terms. Lambda, mean free path, root 2, pi. D is called as collision diameter, or in simple, right, what is the diameter of a molecule? That's it. N is number of molecules per unit volume. Ye N has to be found out. Rearrange kar le. N equal to 1 by root 2 pi d square lambda. Okay. 1 by root 2 is 1.414. pi is 3.14, d का वैल्यू कितना है? अरे 0.26 नैनोमीटर, so 0.26 into 10 power minus 9 meters square है, right? Multiplied by lambda का वैल्यू कितना है? lambda, अरे 2.6 into 10 power 5. ठीक है, मैथमेटिक्स कर ले, हाउ मच यू विल गेट 1.281 into 10 power 23 मिल जाएगा, which is option C here. Got it? समझ में आ गया? Meru has given me the option C. Very good. Yes, that's a correct. Lakshman, yes. All in one. It's not option D. I hope you understood, right? हमारा answer मिल जाएगा option C. अरे there is the answers are very close, so I won't say that okay you got the wrong one, because 1.281 and 1.81 में बहुत छोटू difference है. So yes. Okay, last up wrong हो गया इसीलिए, कोई बात नहीं. Anyway, you got the correct answer for that. That itself is an amazing thing. Okay. So yes, moving on. Moving on to the next one. Here we have. Okay, bye bye Maru. Good evening. Yeah, have a great day. Same. First part of the question is same, but the final question is a bit different. That's all. Question here is calculate the pressure of the gas. Question ये है कि calculate the pressure. We already have number of molecules per unit volume, right? Okay. So from there actually we can develop the answer. Yes? Okay, all good, all good, all good. Jaldi, fatafat. Answer for this. Which one? Can I solve? Okay. As you all know, first part of the question is same. As first part of the question is same, we already have the value of n, which is number of molecules, total number of molecules per unit volume. How much was it? That is 1.281 into 10 power 23. This was 1.281 into 10 power 23. ठीक है. Now from here, is it possible to get pressure? बिल्कुल. How? Because you know that PV is equal to small n RT. This n is equal to number of moles. How will you write? Total number of molecules by Avogadro number R into T. That is equal to PV. ठीक है. देख ले. R by Na is what? Kb. Okay, this is Kb into T, that is N is equal to PV. You want N by V value here, right? So N you have, V you have. So N by V is equal to P divided by Kb into T. Very important. For next question also we need this, so you can write it down. N by V. This number of molecules per unit volume. Let me tell you, ये n और ये n पे फर्क है. This is number of moles. Okay. Don't get confused. This is number of molecules per unit volume. We are using the same symbol here, but used in different situations. So don't get confused. Okay. ठीक है. So this I'm going to write n by v is equal to P divided by kBt. This is equal to 1.28 into 10 power 23. So pressure is equal to 1.28 into 10 power 23. Kb is equal to 1.38 into 10 power minus 23 into temperature 300. So how much will you get? We will get this as 530 Pascal. Is it clear? We can go with the first one as our correct answer. Is it clear? Yes? First one will be our correct answer, which is 530 Pascal. If it's clear, let me know. If it is super clear, let me know. Lakshman A, Pratik A, yes. Yes. Go through all the steps which we have followed. I don't want you to be have any confusions with any of the steps we have done here. So बच्चा लोग जल्दी से प्यारा से ठीक है taking enough time go through all the formulas here. So all clear I suppose है ना ठीक है फिर तो बढ़िया. Next. Next question is all in front of you, and actually we can say if we have done previous question ye karne pe nothing is there. Okay, so yes, expecting the answers from you as soon as possible. Lakshman, yes. Pratik A, all in one S. Okay, yes, clear. Good, good. Do we have the answer for this? Do we have the answer? Chetan is going for option B here. Okay, actually it's a question mark also. Let's see Chetan. Okay, let's find out together whether the option is B itself. All in one is like going for option B. ठीक है सब बोल रहा है कि option B है. Let's do this. If the pressure in a closed vessel is reduced by drawing out some gases, the mean free path of the molecules. What is the general formula for mean free path? That is equal to 1 by root 2 pi d square n. Now we already have substituted for this n in the previous question. देख ले n is equal to n by v p by kbt, right? Chota n equal to p by kbt. We already did the derivation. So I'm going to substitute the same here. So this will be equal to 1 by root 2 pi d square p divided by kbt. So question is only related to mean free path and pressure. So you can write lambda is inversely proportional to pressure. So if pressure is reduced, inversely proportional, pressure to reduced हो गया तो mean free path will increase because they hold an inverse relationship. So simple. So the answer is it will be increased. Pressure to decrease हो गया, mean free path will be increased, and that's what our answer is. Have a look, बच्चा लोग. No doubts, है ना? So yes, Lakshman has also given A, B. Which one? Which one will you choose, Lakshman? A or B? B, I suppose. Finally, you have chosen option B. It says it's increased. Okay, next one. Here we have. Array, this one we can actually write what is the answer. है ना? The relation between the mean free path lambda and the pressure P of any gases. क्या है? Lambda is inversely proportional to pressure, right? Lambda is inversely proportional to pressure. Just now we have explained, or lambda is proportional to P raised to minus 1. Taking this to the numerator. Okay, lambda proportional to P raised to minus 1. Option B is our correct answer. All good? All good? Okay, so moving to the final question. Final question from molar heat capacity. Here we have the final question. With that, we will be winding up today's session. Last question है. I want every one of you to give पूरा energy, total energy से. With complete energy, आंसर दे दे बच्चा लोग जल्दी से नन्नू मुन्नू बच्चा लोग. What can be the answer? हाय प्रीति, मैं तो बिल्कुल बढ़िया. So you have a great body. Thank you so much. Are you all going for option B here? Lakshman going for option A, 5r/2. Okay. Monica Monu, option A. Then Lakshman, option A. ठीक है. Everyone is going for option A here, which is 5r/2. There is a small problem with this. Anyway, I'll write. Question is diatomic molecule not rigid. Underline कर लीजिए. Okay, which has a vibrational mode. Then what is CV equal to? CV का formula क्या है? CV का formula क्या है? CV is equal to F times R/2. Okay, so substituting the degree of freedom will give us the answer. Now, most of you, once listening to the word as diatomic, might have gone with value 5 for degree of freedom. But it's not always 5. I have told you in the previous question. Those who were there in the class at that time must have given the correct answer. For diatomic, I'll write it again. Same thing I have told in the same class. For diatomic, if it is rigid, if it is not vibrating, degree of freedom 5 hota hai, which we already know. Now, diatomic molecule, if it is not rigid, if it is having vibrational energy also, degree of freedom kitna hota hai? 7. Here, what is the case here? मेरा बच्चा लोग, इधर का केस क्या है? Not rigid situation है. Not rigid situation पे diatomic will have a degree of freedom of 7. So that's why this is 7 times R/2, not 5 times R/2, which we all have thought about. Clear? ठीक है? So our correct answer will be option C here. Okay, not B and all. A भी नहीं, B भी नहीं, D भी नहीं, C है हमारा correct answer. Okay, so tell me, how was the session, everyone here in this class? Session कैसे था? बच्चा लोग, everyone, प्यार से बोल दे. प्यार से बोल दे बच्चा लोग. And there is one more way for every one of you to show some love. Move your cursor, click on that like button and do let me know that you have enjoyed the class. That is also an amazing way, right? To show some love, to tell that sir what you did is commentable, and we do appreciate that. Awesome, Chetan, good to know that. Awesome, awesome, every one of you. So, ठीक है. Now I'll just help you with some of the things. If you really would love to have a scholarship when you join colleges, this is your best chance. Unacademy Prodigy program. The last exam is going to happen on Feb 27. Don't miss your chance from 12 to 1 p.m. This is completely free. If you want to enroll for free, use the code of AMB10. ठीक है. Thank you so much, Soumya. Thank you so. Okay, so class 11th batch course is what you can see it over here. You can be a part of it and can enjoy a great class with amazing teachers. Special class timetable. Today at 4:30 we are having a class, right, of complete revision of all the chapters for term 2. You can come and join, right, a special class at 4:30 today. It is also completely free. You just need to use the code of AMB10 for that. Today at 4:30, right? Now, special class are completely awesome because here we have live chats, question tabs, polls, leaderboards. Everything is going to be awesome. One more thing, if you are going to make the subscription now, along with 3-month subscription, 1 month is given free only for the first 500 subscription. Make use of it. So thank you so much, everyone. Like I said, you can like the class and share it with all your friends. Subscribe to the channel. Okay. So thank you once again, मेरे बच्चे लोग. See you all in the next classes. Till then, bye bye and take care.